Good day, students. In this clip, we're going to be reviewing some problems on graphs of trig functions. So let's take a look at question number 1. So it says, give the amplitude and period of the graph. So we have this graph below. If you examine this closely, what kind of trig function does this look like? Is there a real quick review? Remember, your sine function looks like an S. If it's positive, the sign goes up like this. That's one period. If it's negative, it goes in the other direction like this. And your cosine function looks like a cup. So one period of your cosine function, if it's positive cosine looks something like this. So let's write this. This is positive sine, and the red one is negative sine. And then for this one, you see this cup orientation. That is the positive cosine. The positive cosine starts from the maximum, okay? And the negative cosine starts from the minimum and goes in the opposite direction like that. So that is a negative cosine. Okay, let's take a look at this graph. What does this look like? Looks like the cup starting from the maximum. So this is a positive cosine function, okay? Now it asks for the amplitude. The amplitude is a displacement from the center to the max or center to the min, okay? So this is a central position. The midpoint from the tip from the maximum points to the minimum points. This is the central position, center. And we have the maximum, which is where all the peaks stop at. This is the maximum displacement from the central position, and this is the minimum displacement, okay? So we have our center, max, and min. Now note, the amplitude is not a displacement from the min to the max, it's a displacement from the center to the max or min. So I can either compute this distance from here to here, or I can compute this distance from here to here, okay? So how many units displacement are there from the center to the maximum or from the center to the min? That will tell us what our amplitude is, and we can clearly see that it's 4. I kind of covered it up a little bit. So this is 4 units, okay? So that's our amplitude. Now to calculate our period, there are different ways we can calculate our period. One complete cycle is a period. So we had the maximum here. From this maximum to the next maximum on this graph, that will be our complete period. So we can go from maximum to maximum. That length will tell you the period. Or you can go from minimum to minimum. That length will tell you the period also. Okay, so let's do from max to max. From max to max, we can clearly see that the length from this max to this max is 4 units. No, I'm sorry, it's 8 pi units. From here to here, it's 8 pi units. So the period is 8 pi. All right, so let's write this down. The amplitude we found before, from the center to the maximum, is 4 units. And the period from max to max is from 0 to 8 pi is 8 pi units long. So we can clearly see that our answer is option letter D. Okay, let's take a look at number 2. We are asked to sketch the graph of these 3 functions and basically say what their similarities and differences are. All right, so let's start with function number 1. We are going to be graphing 3 cosine functions. So let's start with the first one. But before we do that, let's write down the general form for the equation of trig functions. So we have y is equal to a cosine bracket b x minus h plus k. Okay, so that's what we're going to be using to generate the graph of this function. So let's start with the first one. We have y. I'm going to write this function in this format, okay? The coefficient of cosine is 1, y equals 1 cosine. The coefficient of the x is 1, so we have bracket 1 times x minus h. Let's change the h to a 0, since we're not subtracting anything from the x, so x minus 0 plus 0. Okay, if you have just x by itself, nothing being added to it, you have 0 and 0 here. Okay, now let's determine what the new origin is, where our graph is going to be centered. New origin is going to be 0, 0. So we can see that our phase shift is 0 and our vertical shift is 0. Let's figure out what our period is. Our period is 2 pi over b. 2 pi over b. In this problem, b equals 1. So we have 2 pi equals our period. And that tells us that 4 ticks is going to be equal to 2 pi. Okay? If you notice in this calibration we are using degrees, so if we want to write this in degrees, we're going to have 4 ticks equals, pi is 180, so 2 pi is 360 degrees. Alright, so I think that's enough information to graph this function. Oh yeah, we also need our amplitude. Our amplitude is A. Amplitude is the absolute value of A, so we're going to be computing the absolute value of 1, which equals 1. Alright, now let's go ahead and graph the function. So we are starting from 0, 0, and our amplitude is 1, so let's graph a 1 here. That's how high our function is going to go, and then it's going to go as low as 1, like that. Okay, so 4 ticks is equal to 360 degrees, so let's go ahead and do our calibration. So we have 4 ticks is equal to 360. So we have, if we break 360 into 4, we'll end up with these 4 ticks here. 90, 180, 270, and 360. So we have 360 divided by 4 is 90 degrees. Alright, so let's go ahead and graph the cosine function. We know that the cosine looks like the cups, so let's graph that. I'll graph the first one in red. So we have, it starts from the maximum, goes to the center, minimum, center, and right back to the maximum. Okay, so that's what our cosine function looks like. Let's connect the dots. So first, just a sketch. So something like that. It ends there. Okay, let's graph the second one. We have function number 1 graphed. Now let's graph function number 2. Let me do the entire thing in green. So function 2, let's write y equals cosine 4x in the general form right here. So it's going to be y equals 1 cosine. You notice that b is 4 now, so 4 times x minus, nothing is being subtracted from x, so 0. Nothing is being added to the entire function, so it's plus 0. Okay, let's find our new origin. New origin is going to be the opposite of the letter next to x, which is 0, and then the number that's been added or subtracted from this term, which is 0 also. Our period is going to be 2 pi, or let's use 360 this time. 360 and 2 pi are the same thing. So 360 over b is 4, so 360 over 4 is going to be equal to 90. Alright, and our, so that tells us that for our calibration, 4 ticks is equal to 90. Alright, how about our amplitude? Amplitude is the value of A. In this problem, we can clearly see that A is 1. That's the coefficient of cosine. So we have absolute value of 1 equals 1. So that's enough information to graph. Let's go ahead and graph the function. We're still graphing cosine. Let's do the first calibration. 4 tick marks equals 90, so we have to divide this 90-degree region into 4. So the quickest way to do it, we split it down the center like this into 2 halves, and then go on to split the halves you created into another set of halves. Okay, so split this down the center like this, and split that down the center like that. Okay, alright, so we can graph it there. So starting from the max, we have max, center, min, center, max as one complete period. We can see that it is much smaller than the other one. It has a much compressed period. So you graph it like that, and that pattern basically continues for the entire region. Okay. All right. So that's our second function right there, function number 2. Now let's graph function 3 and see if we can make a comparison. So for function 3, we have y equals 4 cosine x. Now, let's write this function in this general format here. So we have y equals 4, that's now a, cosine. The coefficient of x is 1, x minus 0, plus 0, because nothing is being added or subtracted to the x, and nothing is being added to this whole term right here. Now let's find our new origin. New origin is 0, 0. Opposite of the number next to x is the x coordinate, and then the other number is the y coordinate. Our period is 2 pi over b, or we can use 360 is the same thing as 2 pi radians, 360 over b, which is 1. So that's going to give us 360 degrees. So that tells us that 4 ticks is equal to 360 degrees. Okay, so each tick will be 90 degrees. And lastly, we need our amplitude. Our amplitude is the value of absolute value of A. So absolute value of 4 is 4 units. So we're going to have a displacement of 4 units up and down from the central position. Okay. All right, we have all the information we need. Let's go ahead and graph it. Our maximum is going to be at 4 this time because of the amplitude of 4. And our minimum is going to be at negative 4. Calibration will be the same as the first graph we drew, function number 1. So 4 tick marks, 1, 2, 3, 4. 4 tick marks being equal to 360 degrees, as we can see here. We are still graphing our standard cosine function, so we start from the max, center, min, center, max, and then we connect the dots. Okay, so it goes like that, like that, like that, then like that. Okay. Okay, let's go ahead and compare the graphs, similarities and differences. So I can just title it comparisons. What do we notice here? Periods. The green one is 2, the red one is 1. So we notice that the first and the second one have the same amplitude. Okay, so functions 1 and 2 have the same amplitude of 1, right? It's obvious on the graph. What about functions 1 and 3? They have the same period, right? Another similarity, functions 1 and 3 have the same period. Is there a similarity that all 3 functions share? Absolutely, they all start from their individual maximums. Okay, the individual maxima. So functions 1, 2, and 3 start at their maximums. Okay, the maxima. Now let's take a look at another example. So for question number 3, you're to graph y equals tan 1/2 of x. We're going to include vertical asymptotes in our sketch. Okay, so first of all, to know where the asymptotes are at, we need to express tan using the quotient identity. Okay, so we know that tan x is equal to sine x over cosine x. So cosine basically tells us where the asymptotes of tan is. And we also have to recall that the tan function at something like this, it goes from negative infinity to infinity at every period. All right? Okay, so now since we're looking at tan x, to graph tan 1/2 x, we graph cosine 1/2 x. Now, why do we graph cosine 1/2 x? Because that is the function that tells us the locations of the asymptotes. Anytime the denominator is 0 or cosine 1/2 x has a value of 0, the tan function has a vertical asymptote. Okay, so let's go ahead and graph that. So we have y is equal to cosine 1/2 x. Let's write it in the form that makes it easy for us to determine its components. So we have y is equal to 1 times cosine, and factor out 1/2, times x minus 0 plus 0. Okay, now this is easy for us to find the relevant components. Let's find a new origin first. The new origin for our cosine function is 0, 0. Our period is 2 pi over b, and we can clearly see that b is 1/2. So we have 2 pi over 1/2. How do you divide 2 pi by 1/2? We're going to multiply the numerator by the reciprocal of the denominator, which is a fraction. That is the same thing as dividing, okay? So we have 2 pi times 2 over 1. We'll multiply it across. We have 4 pi. That's our period. So this tells us that 4 ticks will be equal to 4 pi. That's our calibration process. Okay, let's see, our amplitude here, although it's not useful for this graph, let's just state it. Our amplitude is the value of A, which is our absolute value of A, which is 1. All right, so I'm going to sketch the cosine curve. All that we're doing is just basically using the cosine curve to determine where the asymptotes of our tan, of the related tan curve is located, all right? So that's our max and min. I will take that out momentarily. So that's a max and min. So let's go ahead and do the calibration. How do we calibrate our x-axis? We have 4 ticks. 1, 2, 3, 4 is going to be 4 pi. Okay, going the other direction. 1, 2, 3, 4. That'll be negative 4 pi. All right. Now let's put our points for our cosine function. Remember, your cosines looks like the cups. So you start from the maximum for a positive cosine like that, okay? So let's start from the maximum. Center, next tick, center, next tick min, next tick center, next tick max, all right? Going in the other direction, center, minimum, center, max. Now I'm going to draw my cosine function, cosine curve using, you can use a dotted line to draw it. All right, so let's just make it a dotted line. You don't really have to draw your cosine curve because it's just telling us where the asymptotes are at. The only points I care about are the points where cosine has a value of 0. Because when cosine has a value of 0, you have a vertical asymptote for tan. So can you see where the vertical asymptotes are at? They are the roots of the cosine function, right? So here it hits 0. Let's indicate where they are located. We have an asymptote here, 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 and here. Okay, so let's graph the asymptotes. So the first one, second one, let's do that again. Second one, third one, and then we have the fourth asymptote. All right, and then we follow the general pattern that the tan function follows, as we illustrated earlier. It's kind of like it goes from negative infinity up to infinity for every period. So let's sketch what that looks like. So starting from the center, it's going to go to infinity, and then start from negative infinity to the center, from the center to infinity, and then from negative infinity back to the center. That pattern continues forever. Okay? So that's basically what your tan function looks like. From the left-hand side, it goes from negative infinity to the center, and then on the right side, from the center, it goes all the way to infinity, and then this one from the center towards infinity. Okay, so that's the graph. This is a graph of tan of 1/2 x. Okay, let's take a look at another example. All right, it says select the equations that could represent the graph below. Okay, so this is number 4. So this is a trig function that has been phase shifted either to the left or to the right. I want to consider a phase shift to the right here. That's the closest maximum. So let's draw our new y-axis somewhere over here. So the question now is, what kind of function is this? What kind of trig function starts from the maximum and starts to exhibit this periodic behavior? This is your cosine function. Okay, so we know that that's a cosine function. 1, 2, 3, 4, 5. We know the amplitude is 5. It's positive because it starts from the maximum. If it were negative cosine, it will start from the minimum. Now, the phase shift is the number of units that it's shifted to the right. Okay, so it had a phase shift here. So the question is, how many units was it shifted to the right? Now let's look at our options. We have 2 possible candidates, either 2 pi over 3 or pi over 3. So what is the accurate phase shift here? Well, it has to be smaller than pi over 2. The only degree measure that's smaller than pi over 2 and bigger than 0 is pi over 3. So our phase shift is pi over 3. Okay? So now we have enough information to write down the first equation of our graph. Is going to be y equals, the amplitude is 5 cosine, 5 cosine. You notice all the options have a period of 1, so let's not bother about that. Let's just focus on the phase shift, x. Now, if you shift pi over 3 units to the right, is that a plus or a minus pi over 3? It's, you do the opposite, right? So it's minus pi over 3. So you can clearly see that the first option is option letter C. Now, which other candidate could satisfy this equation? Okay, so I told you all in class that I will provide you with an identity that you use to find another equivalent function with this graph. The co-function identity applicable to this problem is the identity that helps you express a cosine function as a sine function. Okay, so the identity that we're going to use is the co-function identity sine theta plus pi is equal to cosine theta. What does this mean? This means that if you have a sine function and you shifted pi units to the left, what you end up with is a cosine function. Okay? All right. Oh, slight mistake. This is wrong identity. I meant to say negative cosine. Negative cosine. So if you want to express cosine, use a negative cosine. All you do is basically shift the cosine function pi units to the left. All right. So let me just show you what I'm talking about real quick. So if you have, let's say you have a cosine function, something like this. If you reflect it, it goes like that, and then when you shifted pi units to the left, you end up with what you started with. All right, so there are a lot of co-function identities, but this is the one that's applicable to this problem. And on the test, I will provide you with the identity. Okay, so you have negative cosine is equal to that. All right, so this function tells me if I want to express cosine as a negative cosine, I just have to add pi to the angle. Okay, so let's do that here to see the negative cosine equivalent of the result that we got. So it's going to look like this. Y equals negative 5 cosine. Now that I have changed my cosine to negative to compensate for that change, to have exactly the same function that I started with, I need to add pi to my angle. Okay? Alright, so to finish it off, we just put this over 1 times it by 3 top and bottom. And then we have, this becomes negative 5 cosine x minus, let's see, minus pi over 3 minus, let's write it out, minus pi over 3 plus 3 pi over 3. And then your final answer is going to be negative 5 cosine x plus 2 pi over 3. All right, and we can clearly see that our answer is option letter B. Let's shift our attention to the next question. It says, which of the following graphs accurately shows y equals negative 2 secant x? So we have 4 asymptotic trig functions, and they have their asymptotes are determined either by sine or cosine. Okay, so let's go over those real quick. Yes, the 4 asymptotic trig functions are tan, cotangent, secant, and cosecant. Okay, tangent is given by sine over cosine, which tells us that cosine determines its asymptote. Cotangent is given by cosine over sine. So sine basically determines where the asymptotes of cotangent is. Secant is given by 1 over cosine. So cosine determines where its asymptotes are, just like tan. Okay? And then cosecant is 1 over sine. So sine determines where the asymptotes of cosecant is, or are. All right, now let's take a look at this option right here. The problem tells us that y is equal to negative 2 secant x. So the asymptotes of secant, since we know secant is 1 over cosine, the cosine function helps us to determine where the asymptotes are. But we have to be careful here, there's a negative. Okay, so we're going to be looking at the negative cosine. So what does a negative cosine function look like? Remember, the positive cosine is like a cup opening up, so the negative cosine is like a cup upside down. All right, so the dotted line represents the function that helps to determine the location of the asymptotes. So if you look at this right here, this dotted line is negative cosine. This dotted line right here is positive cosine. Let's put, this is negative 2 cosine. This is 2 cosine. This dotted line here, you know what it is? It's like an S. This is a negative 2 sine, starting from the center. And this one right here is 2 sine. So which of these accurately helps us determine y equals 2 secant? Since secant, negative secant is dependent on negative cosine, this answer, option A, will be our correct answer because it accurately determines where our asymptotes are at, which is basically the points where negative cosine x hits the x-axis or has a value of 0. All right, so there you have it. Okay, let's take a look at the next question. We asked to graph y equals tan x plus pi over 2. All right, so to graph this, we just need to remember what the general appearance of the tan function looks like. Remember the tan, starting from the center, just heads to infinity at the asymptote to the right, and into negative infinity to the asymptote to the left, and exhibits the same behavior forever. Okay? So the function that exhibits that increasing behavior from the left asymptote to the right asymptote are option C or D or B. Okay, let me not circle that. That's not good. So I'm going to eliminate option A. Okay, this could be a cotangent or negative tan. So now we notice that there's a phase shift here. X plus pi over 2. What does that mean? If you have y is equal to tan times x plus pi over 2, what kind of phase shift is this? Plus pi over 2 means you shifted pi over 2 units to the left. Okay? So pi over 2 units shifted to the left in the left direction. Okay, so let's see which of these have engraphed pi over 2 units to the left. If none of them have meets that description, then D will be our final answer. Okay, so pi over 2 units to the left. We have 1, 2, well, we have 1, 2, 3, so this is where pi over 3 is right there in the center. Then over here, 1, 2, 3, pi over 3 is right in the center. So which of them fits the description of a tan curve that's shifted pi over 2 units to the left? And we can clearly see that it's option letter C because this value right here is pi over 2, and we've been shifted pi over 2 units to the left, which is represented by tan of x plus pi over 2. All right, let's take a look at the last question. It says, the graph of y equals cosecant x has the same set of asymptotes as which of the following graphs? So remember, if we express these ones using the appropriate identities, we can know where their asymptotes are located. Okay, so we know that y equals cosecant x can be expressed using the reciprocal identity as 1 over sine x. So if any of these functions has a sign in the denominator, if we use a quotient or reciprocal identities, then that will be our correct answer. All right, so option A, y equals secant x is equal to, can be written as 1 over cosine x. Option B, y equals sine x, cannot be expressed using a quotient identity or the reciprocal identity, so we'll leave it alone. Y is equal to cosecant 2x is equal to 1 over sine 2x. Now last but not the least, y is equal to cotangent x is equal to, let's see, what is this again? It's cosine over sine x. Okay? So this one and this one, they both have a sign in the denominator, so we know it can be A or B. But which of them is the correct answer? Notice the original problem calls for there to be sine x in the denominator, but this has sine 2x, which is a problem, but this has sine x, and this is exactly what we want. So we know that option C is not an answer. Your final result is option letter D. This function and this function have exactly the same asymptotes. Okay? They don't look alike, but their asymptotes are identical. All right, so that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel so you can get updates to other cool clips such as this. And please post a comment to let me know what you think about this clip. More clips can be found on mathgoserve.com. Thanks again for watching and have a wonderful day.